some series integral calculus. Summation of a series through integral calculus. This is what discussion we are pursuing, and whatever we are going to talk, I am sure that no one would have seen in the book, or wherever the resources are. That is addition of a Fibonacci series. Can we add a Fibonacci series? That is a big thing. Okay, people have derived how to derive a summation series, some series into algebra. That is the first question. If I see Fibonacci series, then I have x-axis. Okay, if I talk about okay, if I talk about Fibonacci series, consider I have x-axis. If this is x-axis, this is x-axis. What is Fibonacci series? If this is x-axis, then this is various. Okay, if this is x-axis, then this is various points on x-axis. X equal to 0, x equal to 1, x equal to 2, x equal to 3, x equal to 4, x equal to 5, and so on. Okay, if it is x equal to 0, x equal to 1, x equal to 2, x equal to 3, x equal to 4, and so on. This is the value on x-axis. Consider this is y-axis. Okay, this is x-axis, then this is y-axis. Okay, now let's take values now. If x equal to 0, consider this is a box. X equal to 0 has a box. X equal to 1 has a box. X equal to 2 has a box, and like so on. If that is the case, then in box of x equal to 0, there is a number that is 0. X equal to 1, there is a number called 1. X equal to 2, there is a number called 1 again. X equal to 3, there is a number called 2. X equal to 4, there is a number called 3. X equal to 5, there is a number called 5. X equal to 6, there is a number called 8. How it is calculated is x equal to 0 and x equal to 1 has numbers 0 and 1. That is fixed. X equal to 1 has a value of addition of previous two. 0 plus 1 is 1. Sorry, x equal to 1, 2. X equal to 3 will have value addition of previous two. That is 1 and 1, that will be 2. X equal to 4, 2 plus 1, 3. X equal to 5, 3 plus 2, 5. X equal to 6, 5 plus 3, 8, and so on. This is called Fibonacci series. If I draw in a chart, if I draw in a xy plane, then at x equal to 0, there will be a height of 0. At x equal to 1, there is a height of 1. X equal to 2, there is a height of 1. X equal to 3, there is a height of 2. X equal to 4, there is a height of 3. X equal to 5, there is a height of 5. X equal to 6, there is a height of 8, and so on. Okay, can if I say x equal to 10, x equal to 10, then how much the value of 10 will be? Then it will be summation of x equal to 8 and 9. Okay, what is x equal to 9? Then it is summation of 7 and position at 7 and 8, like so. It will come backward, and then finally it will fetch the fixed information that is available at x equal to 0 and x equal to 1. Okay, now the question is arising if I say x equal to 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. X equal to 10. If x equal to 10, then what is the value that is stored there? Then someone would say, okay, you have to calculate one thing. Second thing, if I say x equal to 10, then from x equal to 0, if I add up to 10, how much is the addition? That is the another question that will be fired. First question is when x equal to 10, when x equal to 10, then what is the value? When x equal to 10, then what is fx? First thing. Second thing is when x equal to 10, then what is the summation up to x equal to 10? What is the summation up to x equal to 10? That is the next thing. Okay, what is at x equal to 10? Function over x, that is the value at x equal to 10. Function over x equal to function over x minus 1 plus function over x minus 2. Whatever is there at x minus 2 means at the 8th slot, and whatever is there x minus 1 means 9th slot. If someone add, he will get function over at 10th slot. That is one thing. What is summation of all the slots up till 10th, including 10th? That is 0 plus 1 plus 1 plus 2 plus 3 plus 5 plus 8 plus 13 and so on up till whatever we have at 10. This is what we are talking now, summation series. Someone would have questioned how we generate the algebraic. Okay, if I talk about, first of all, if I talk about summation, this is what we are talking. What is the summation? What is the summation till x equal to 10? If I talk about summation till x equal to 10, then we will proceed in divide the problem. Now we can exclude x equal to 0 because it is 0 only. We'll start with x equal to 1, which has value 1. X equal to 1 to x equal to 10. There are 10 numbers are there. Let's divide into 10 different parts. Each part, first part is 1, second part is 1, third part is 2, fourth fourth part is 3, fifth part is 5, sixth part is 8 and so on up to 10. I have to add up to 10. I have to add up to n. Let's divide into n different parts. First part is 1, second part is 1, third part is 2. Can I have an algebraic equation so that all parts should behave exactly same? This is what we had started a discussion with. Okay, I mean in notebook I am writing 1 plus 1 plus 2 plus 3 plus 5 plus 8 plus up to 8 plus slot number 1, slot number 2, slot number 3 up to 10. 1, 1, 2, 3, 5, 8 and up to 10. If I am trying to add all this, then what will be the result? Okay, let's find rather than adding all the different number, can I add same number? Okay, then it will be some variable will come into the picture. Yeah, which variable you tell me? Okay, okay. I am not talking about it how to bring it, but I have seen it and how people can generate it. That we will talk in differential equation. Differential equation. Like if I say I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Can you bring it to algebra? Then if I say at any x I have fx, then what is dfx by dx? Makes sense. If I want to calculate, if I want to represent 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 function number as algebra, then how I can represent? Consider that it is a function over x. Means when x equal to 5, then I have to find the number. Means slot number 5. X is slot number. Okay, then someone would say easiest differential equation dfx by dx. How much fx? Fx at x equal to 1 is 1, fx at x equal to 2 is 2, fx at x equal to 10 is 10. Okay, what is fx? What is fx? Whatever fx is, dfx by dx, the change in fx per unit change in x is 1. That is for sure. If x is 5, then I have value at slot number 5 is 5. If x is 6, then slot number 6 value is 6. Means if dfx by dx at x equal to 5, per unit change in x brings how many unit change in fx? That is 1. Means dy by dx equal to 1. dfx by dx equal to 1. dfx equal to dx. fx equal to x. X is the equation. Similarly, this will be little complex one. How to find? If I say I want to represent each value, each slot in fx, function over x, then what is dfx by dx? It should come to linear. The concept is linear. If it is not linear, then I have to find how it is. Okay, if I say x equal to 4, then I have value as 3. Hope I have value as 3. X equal to 5, then I have value as 5. X equal to 6, then I have value as 8. dfx by dx at any equal to what? I don't know. That I have to find out. Or d2fx by dx square, is it constant? Whatever. Or in some complex algebraic, complex differential equation, I have to represent this number, then solve it. Someone has solved it. If someone has solved it, he found that the function over x is actually phi 1 to the power n or phi 1 to the power x minus phi 2 to the power x by square root of phi. So differential equation by getting that dfx by dx or d2fx by dx square or d3fx by dx cube, like that, then doing some complex manipulation, someone found that the every x slot number x has function fx as phi 1 to the power x plus, sorry, phi 1 to the power x minus phi 2 to the power x by square root of phi, where phi 1 is 1 plus a square root of phi by 2. Phi 2 is 1 minus a square root of phi by 2. I believe it is alright. Okay. Phi 1 is 1 plus a square root of phi by 2. Phi 2 is 1 minus a square root of phi by 2. So net fx equal to 1 plus square root of 5 is 2.23, around 2.23. Okay, then it will become 3.23 by 2. That will become 1.6. For simplicity, let's take 1.6. So it is 1.6 to the power x minus, and then 1 minus the square root of 5. 1 minus 2.2, that will be minus 1.2 by 2 minus 0.6. So fx equal to 1.6 to the power x minus, and then in bracket minus 0.6 to the power x by a square root of 5, that is 2.23, 2.2 whatsoever. This is the algebraic representation of Fibonacci series. Okay, if x equal to 1, the actual is phi 1 to the power x minus phi 2 to the power x by a square root of 5. Okay, in that manner phi 1 equal to 1 plus a square root of 5 by 2, phi 2 equal to 1 minus a square root of 5 by 2. Okay, first will become 1.6 to the power x minus, and in bracket minus 0.6 to the power x by a square root of 5. This is fx. If I keep x equal to 1, where there we have started, it will be 1.6 minus, and then in bracket we have minus 0.6 to the power x, that is nothing but minus 1 to the power x into 0.6 to the power x. Okay, I can break it and it would become like that only. Minus 1 to the power x means for odd number that will be negative, and negative is waiting outside. So for odd number it will become like 1.6 to the power x plus 0.6 to the power x for odd numbers by by a square root of 5, that is 2.2. Okay, more or less it will become x equal to 1.6 plus 0.6, 1.6 plus 0.6, that will come at 2.2 by 2.2 1, and indeed it is 1 only. When x equal to 2, 1.6 into 1.6, how much it will come? Okay, 16 into 6, 96, 6, 6, 9, 2, 256, 2.56. 2.6 I can keep, 2.6 plus point. Okay, now it will be different. Now this is even number. When x equal to 2, even number, then 1.6 to the power x minus and minus 1 to the power x, that will become plus, minus is waiting outside, it will become. So for even number, it will be 1.6 to the power x minus 0.6 to the power x by 2.2. Okay, 1.6 whole square is 2.6. 1.6 whole square is 2.6. 2.6 minus 0.6 whole square will be 0.36. I can make it 0.4. 2.6 minus 0.4 will be 2.2. 2.2 by 2.2, 1. Again 1. Okay, someone can try x equal to 3 for odd number. Now we have come to know that if I am representing all the Fibonacci series number as a different number, I can rewrite it as a same number. First segregate odd slots and even slots separately. Odd slot is x equal to 1, 3, 5, 7, 9, 11, something like that. Even slot is x equal to 2, 4, 6, 8, something like that. When x equal to 9, when x equal to odd number, when x equal to odd number, then it is x to the then it is 1.6 to the power x plus 0.6 to the power x by 2.2. If it is even number, then 1.6 to the power x minus 0.6 to the power x by 2.2. Minus is different. Even number it is minus, and in odd number it is plus. This is what we saw. If I try x equal to 2, then it will become, I believe we have already calculated, it will come as 1 1. X equal to 3, then 1.6 to the power 3, that will come as 2.6 into 1.6. More or less it will come around 4.1. 2.6 into 1.6, 96, 6, 9, 16, 16 and 9, that will become 16 and 9. Up. No. What we are trying, 2.6 into 1.6, 16, 6, 6, 9, and 16, 2, 32, 9, 41. 42, it will come at 4.2. 4.2 plus zero point 0.6 into 0.6 into 0.6. 0.6 into 0.6 is 0.36. 0.36 into 6. 6, 36, 6, 21. It will come as 0.21. So it will come as 4.2 plus 0.21. That will come as 6. It will come as 6.3. 6.6. It will come as It will come as plus. Okay. Hope. Okay, total confusion with 0.2 and here 4.2, 6.3 or 6.4 it will come. Downside I have 2.2, that will come at around 3. 3. We have 1, then it should come as 2, not at 3. When x equal to 3, it should come as 2, not as 3. We'll try again. Okay. 1.6, when x equal to 3, it is odd number. So if I try with from the beginning, phi 1 to the power x minus 1 to the power x, yeah, right. Minus x to the power minus 1 to the power 3 will be minus plus, perfect. So 1.6 to the power 3 plus 0.6 to the power 3. Okay, 1.6 to the power 3. First 1.6 into 1.6. 1.6 into 1.6 is 2.6. 2.6. 2.6 into 1.6. 2.6, 1.5 will be 3.9. So we are calculating around 4.2. It will come as 4.2. And this side will be 0.6 into 0.6 into 0.6. That will be 0.36 into 0.6. 6, 0.21. So 4.2 plus 4.4. 4.4 by 2.2, perfect. Okay, so whoever has thought it, he has thought perfectly. Now question is arising. So we have found the algebraic equation for odd number and for even number. Now they have different. For odd number, if I go for the odd number, then it will come as 1.6 to the power x plus 0.6 to the power x by 2.2. If it is for even number, 1.6 to the power x minus 0.6 to the power x by 2.2. Okay, now let's settle down the odd number calculation. First, let's settle down the odd number calculation. Okay, if I go for calculation of odd number first, let's divide into different sections where each section is 1.6 to the power x plus 0.6 to the power x by 2.2. Okay, that is the case for the each section. We will go by the successive approximation. This is what is the perfect result we are getting. If I go by successive approximation, then consider this is x-axis, and when x equal to 1, I have a vertical of 1. When x equal to 3, I have a vertical of 1. When I'm sorry, when x equal to 1, I have vertical of 1. When x equal to 3, I have a vertical of 2. When x equal to 5, I have vertical of 5. X equal to 7, then I have vertical like that. Someone is asking me to make a summation up till x equal to n, not n terms. X equal to n. If x equal to n, then I have to add all the vertical. If I connect top point of all the vertical, if I connect top point of all the vertical, then it will become a function. Top point, top point, top point, top point. If I connect like this, it becomes a function. If it becomes a function, the equation of function is 1.6 to the power x plus 0.6 to the power x by 2.2, or a square root of 5, where x is the slot number 1, 3, 5, 7, something like that. Okay, now if I see closely, if I watch closely, every sampling has two different distance. X equal to 1, x equal to 3. Gap is 2. X equal to 3 and x is equal to 5. Gap is 2 again. There are two sampling. It means if I say that if I am calculating the summation of odd number, then summation x equal to 1 to n function over x, where function over x I can rewrite as function over x plus function over x plus function over x plus function over x plus, so where x is 1, x is 3, x is 5, x is n. Okay, now if I see x equal to 1 and x equal to 3, there is a gap of 2. If I take this up and up and consider this is a discrete function fx, which is sampled discretely, digitally. Okay, if I take another function gx, which is a continuous function, then if I take area between x equal to 1 and 3 like this, it will go and hit gx. This area, this is a fictional function, fictional. Right now I have not fixed it. Okay, then it will, the area will be x equal to 1 to 3, integration x equal to 1 to 3 gx dx, that area. This area would represent the height at x equal to 1. At x equal to 1, whatever the height is, that height must be same as area between x equal to 1 and 3 gx dx. Means when I talk about x equal to n, what is the height at this point? That is 1.6 to the power n plus 0.6 to the power n by 2.2. This height should be exactly same as area between x equal to n and n plus 2, like this. Okay, this area. Okay, so more or less now we can rewrite as summation x equal to 1 to n fx equal to 1 to 3 x equal to 1 to 3 gx dx plus x equal to 3 to 5 gx dx plus x equal to 5 to 7 gx dx plus last one will be x equal to n plus 2 gx dx. Okay, I think it is all right. Okay, this is the way we can say. Okay, now concept is when x equal to any x, then function over x is 1.6 to the power x plus 0.6 to the power x by 2.2. That fx at x equal to x should be exactly same as limit x equal to x equal to x plus 2 gx dx. Okay, I think it is all right. Okay, gx dx. Okay, can someone try solving it? Fx equal to x equal to x, fx x equal to x, that is 1.6 to the power x plus 0.6 to the power x by 2.2 should be equal to limit x equal to x plus 2 gx dx. What will be gx? Is it really possible in reality? That is the question. If it is possible, then find gx. If someone is able to find gx, then he will do final summation limit x equal to 1 to n x equal to n plus 2, n plus 2. dx, and whatever comes in term of n, that will be summation of Fibonacci series of odd number. Then someone has to try Fibonacci series for even number, and then he has to add both, and then he will get the final result. Okay, I would try now, or someone can try someone can try other things also. Let's take another way. Okay, with for simplicity, I gave a theory. Probably we will try in future. Okay, because my experience says that middle one is simple to solve. Middle one is if x equal to, or we can try. Okay, gx dx equal to fx, gx dx equal to fx. Consider 1.6 is a and zero point 0.6 is b. By 2.2, by 2.2 is not there at all. Makes sense? By 2.2 is not there at all. Okay, because at the end we will do 2 by 2.2. There is no problem with that because it's a common denominator. So we have 1.6 to the power x plus zero point 0.6 to the power x. Consider 1.6 is a and zero point 0.6 is b. Gfx equal to gx dx. Gx equal to dfx by dx. Now if I differentiate a to the power x plus b to the power x, it would become logarithmic of a into a to the power x plus logarithmic of b into b to the power x. That is the gx. We will try. Okay, if I integrate a to the power logarithmic of a into a to the power x, it will become a to the power x by logarithmic of a. They will cut down each other and it will become a to the power x. Similarly, plus b to the power x will come after the integration. Now we will set x to x plus 2. That is the concept. X to x plus 2. That is a sub area between x to x plus 2. And that should match fx at x equal to x. If that is the case, then how we can proceed? Okay, now we have a to the power x plus b to the power x, x to x plus 2, a to the power x plus 2, a to the power x plus 2 minus a to the power x plus b to the power x plus 2 minus b to the power x. A to the power x I can take as common factor a square minus 1 plus b to the power x b square minus 1. This is what we are getting. What is expected? Expected is a to the power x plus b to the power x. But we are getting a to the power x into, in bracket, a square minus 1. B to the power x b square minus 1. These are the extra we are getting. So we will try again. Gx we had taken logarithmic of a into a to the power x. We will divide it by a square minus 1 plus logarithmic of b into b to the power x. We will divide by b minus 1, b square minus 1. We will try again. Gx equal to logarithmic of a by a square minus 1 into a to the power x plus logarithmic of b by b square minus 1 b to the power x. If I do the integration, then it will come as b to the power x integration will come as b to the power x by logarithmic of b. A to the power x integration will come as logarithmic of a. They will cut each other and net integration will come as a to the power x by a square minus 1 plus b to the power x by b square minus 1. Make sense? Now we will keep the limit x minus x to x plus 2, x to x plus 2. If I keep like that, then a to the power x will become a to the power x in bracket a square minus 1. B to the power x b square minus 1. They will cut each other again and it will become a to the power x plus b to the power x. This is perfect. This is what we expected. Expectation is a to the power x plus b to the power x, and indeed we are getting a to the power x plus b to the power x. So gx I can take as logarithmic of a by a square minus 1 into a to the power x plus logarithmic of b by b square minus 1 b to the power x. This is gx. This is gx. Okay, if this is the gx, then what will be the final summation of all the odd number? Then it will go from 1 to n plus 2. If x is 1 and n, the last will be n to n plus 2. So integration limit will go from 1 to n plus 2. We will try now. Integration x equal to 1 to n plus 2. And then we have logarithmic of a by a square minus 1 into a to the power x plus logarithmic of b by b square minus 1 into b to the power x. If I go with the integration, then it will come as a to the power x by logarithmic of a, that will cut each other. Remaining will be a to the power x by a square minus 1 plus b to the power x by b square minus 1. Limit is 1 to n plus 2. 1 to n plus 2. If I set it here, it becomes a to the power n plus 2 minus, because it is a to the power x, a to the power n plus 2 minus a to the power 1, a to the power n plus 2 minus a to the power 1. Makes sense? A to the power n plus 2 minus a to the power 1 by a square minus 1 plus b to the power n plus 2 minus b to the power 1 by b square minus 1. If I settle it down, a to the power a to, oh, this is how it is, a to the power n plus 2 minus a to the power 1 is a only, a to the power n plus 2 minus a by a square minus 1 plus b to the power n plus 2 minus b by b square minus 1. This is what is the result we are getting. We have left beginning 1 by a square root of 5 that I can multiply here. So it will become like 1 by a square root of 5 into a to the power n plus 2 minus a by a square minus 1 plus 1 by a square root of 5 into b to the power n plus 2 minus b by b square minus 1. This is the addition of Fourier series in odd number. Okay, can someone try what is the result if I set x equal to 5? X equal to 5 means x equal to 1 is 1, x equal to 3 is 2, x equal to 5 is 5. This is what I remember. 5 plus 2 plus 1, it should come as 7. Let's try it is really coming as 7 or not. 1 by a square root of 5 we will keep outside. Now we have a to the power n, where n is 5 we are taking. A to the power 5. A is 1.6. 1.6 to the power 6. N plus 2, 7. Because I cannot calculate that. Let's try n equal to 3. Okay, it is easy. N equal to 3. Then it will be 3. N 3 plus 2. 1.6 to the power 5. 1.6 to the power 5. 1.6 into 1.6 was 2.6. 2.6 into 1.6 was 4.2. 4.2 into 1.6, how much it will come? 6 into 2, 32. 2. Okay. 66 into 1.6, 16 into 4 is 64. Into 3, 67. It will come as 6.7. 6.7 into 1.6 again. Okay, 6.7, it will come around 10.2, I think. 6.7 into 1.5, it will come around 1. I say 1.4, 1.4 loosely. So it will come as 1.4, a to the power n plus 2, where n is 3, it will come as 10.4. 10.4 minus, hope, 10.4 minus a to the power 1. 10.4, I could have done it better, I think. A to the power n plus 2 minus a to the power 1. A I can keep outside or whatsoever. Okay, whatsoever. Now minus a to the power 1. A to the power 1 minus 1 minus 1.6. Minus 1.6. So how much it will come? Minus 1.6. 10.4 I have taken. 10.4 minus 1.6, that will come at 8.8. I think so. 8.8. 8.8 by a square minus 1. 2.6 minus 1. That will come as 1.6. 1.6. A square is 2.6 minus 1. 1.6. 8.8 by 1.6. Okay, whatever it is, this is how it is. 8.8 by 1.6. Okay, plus same thing we have to try for b. B is 0.6. 0.6 to the power 3 plus 1, 5. 0.6 to the power 5 minus 1, minus 0.6 to the power 1 by by uh, b square minus 1. B square minus 1. Top will be negative, bottom will be negative. Again, it will become positive only. This is what I think so. 0.6 to the power 5, how much it is? 0.6 into zero point 0.6 is 0.6 into zero point 0.6 is 0.36. 0.36 into zero point 0.6 come as around 2.21, 3 times. Now again 0.6, it will come as around 0.12. Again 0.6, 0.6, 0.12, 0.6, it will become like 0.7, 0.7, 0.7 it will come, I think 0.07, 0.07 minus 0.6, minus 0.6, and bottom is 0.36 minus 1. Okay, bottom will become minus 0.7, minus 0.6. More or less it will become 1 only, more or less it will become 1 only, so we can discard it. Now we have 8.8 by 1.6, 8.8 by 1.6 into 1 by 2.2. Okay, 8.8 by 2.2 will become 4 point something, by 1.6 that will become 3 only. 4.2 by 3, up, by 6, by 1.6. Okay, 4.2, 4.2 will be 1.6 into 1.6 into 1.6. Hope we will try again. 4 by 1.6, 4 by 1.6, how much it will come? 4 I can write as, hope it will come near to 3. Someone can try. Okay, this is what we have got. The result what we have got is 1 by 1 by a square root of 1 by a square root of 5, 1 by a square root of 5, and then a to the power n plus 2 minus a to the power 1 by a square minus 1 plus 1 by a square root of 5 b to the power n plus 2 minus b to the power 1 by b square minus 1. Okay, we found that b to the power n plus 2 minus 1, b to the power n plus 2, b to the power n plus 2 minus 1 by b square minus 1, it is very near to 1, very near to 1. Okay, very near to 1, and then multiplied by 1, very near. Oh, I'm sorry, if it is near to 1, then we have to add it. So 1 by a square root of 5 is all right. 8.8 by 1.6 plus 1. 1 was waiting outside, that we were missing. Okay, so 8.8 by 1.6 plus 1. So that will become 9.8 by 1.6. Oh, I'm sorry. 8.8 by 1.6, how much it will come? So 5.5. It will come around 0.5, 5.5. 16 into 5 is 80. 16 into 5 is 80. Then 8 again. 5.5 it will come. 5.5 plus 1, 6.5. 6.5 by factor of square root of 5, that is 2.2. 6.5 by 2.2 is 3 only. 6.6. It is exactly 3. This is what the solution is. When x equal to 3, then addition will be 1 and 2, 3. Someone can try x equal to 5, x equal to 7, x equal to 9. We'll proceed on this and we will calculate for the even number also. And then we will add it and we will come to a big solution in term of n, and then anyone can put in just in calculator and he can calculate the summation. Fibonacci series summation, no one has done it. No, at least I could not find the any algebraic equation for addition of Fibonacci series. Anyway, someone can try now. So this is for odd number, we have got it, that is 1 by a square root of 5 into a to the power n plus 2 minus 1 by a square minus 1 plus 1 by a square root of 5 into b to the power n plus 2 minus 1 by b square minus 1, where a is 1.6 and b is 0.6, or a is 1 plus square root of 5 by 2 and b is square root of 5 minus 1 by 2. Someone can take accurately. Okay, this is giving a perfect result. Someone can try. We will proceed on this. This is not available anywhere. Please do not mind supporting us. +91 is the India country code. 94831 60610 is the telephone number. +91 is India country code. 94831 60610 is the telephone number.